Good day, Bayaws. Today, let's learn another related problems involving fluid mechanics and hydraulics. Chapter 6, Fluid Flow Measurement. In this problem, we're going to be discussing about head loss in a Venturi meter. This is another method of using pressure differentials to measure fluid flow rates, and this is through the use of Venturi meters and either orifice meter. If a gradual constriction has been interposed in a pipe, such as decreasing the area of flow from section 1 to section 2, if the fluid is assumed to be compressible and the respective velocities and static pressures are its velocity 1 and velocity 2 and our pressure 1 and pressure 2. So in this problem, we're going to be discussing about the effect of the changing in the area of a pipe from a wider one to a narrower one. We have a problem. A pipe with a horizontal 120mm diameter gradually shrinks its section to 60mm diameter. Before expanding again to 120mm, the pressure in the 60mm portion had to be reduced by 50 kPa, and it is 114 kPa in the 120 pipe right before entering the reducing section. So in this problem, we're going to calculate the rate of water flow through the pipe if 400mm of head is lost between the known pressure stations. So let's solve this together. We have a pipe here, and this pipe, we have the diameter and its pressure. This pipe, we have a diameter of 120mm. That is from the first section, and on the second section, we can see here that the pipe narrows and reduces its area to 60mm. Here are the givens. Let us note that our head loss, what will happen inside rate of flow of the fluid inside this Venturi meter if there is present head loss, that is 400mm. Let's proceed in calculating the rate of water flow through the pipe if 400mm of head is lost between the known pressure stations. In calculating the rate of water flow, we're going to use this continuity equation, where the Q sub 1 or the discharge 1 is equal to the discharge 2. So we're going to use the energy equation between stations 1 and 2, wherein the energy equation is equivalent to the velocity squared over the acceleration due to gravity multiplied to 2 plus the pressure and the unit weight and plus the height of any there is minus the head loss. Proceed to our calculations. So in this problem, we can see to our diagram a while ago that it is a circular pipe. So since it is a circular pipe, we have a corresponding formula for circular pipes, that is 8q raised to 2 over pi squared and multiplied with acceleration due to gravity times its diameter raised to 4 plus its pressure over the unit weight and so on. Plugging in all the given values to our formula we have, and by simplifying terms, we have a discharge flow rate of the water inside the Venturi meter with a present head loss 400mm, 32 liters per second. In conclusion, the rate of flow of water through the pipe if 400 mm head is lost is going to be 32 liters per second. Find out more about these problems in Fundamentals of Fluid Mechanics 3rd edition of the 2BSABE book, Problem 6 to 42. That's all for today, Bayaws. Thanks for watching. And up next, Chapter 7, Fluid Flow in Pipes.